I'm Dan. Thank you for the live demonstration, and I don't think any of us realized just how easy it was to make a battery. Our next speaker is Mainak Majumder. So he is a professor at, excuse me, I'm just losing my screen here. He is a professor at Monash University. I've known him for quite a long time. He's also one of the founders of Ionic Industries. He's worked across many areas of graphene technology and also very focused on the commercialization aspects, particularly around water purification and supercapacitors. So Mainak, over to you. You'll need to come off mute.
Unmute and share the screen. Can I? Yep. Can you see my screen?
Yes, we can. Well, yes, I can.
All right. Thank you, everyone, AGIA especially, for this invitation to talk in this webinar. It's a 5-minute talk, so it's really going to be a blurb of the most exciting development that has happened in the team in the last year or so. I'm at Monash University, and I'm also part of the Australian Research Council Graphene Enabled Industry Transformation. Monash is one of the major nodes in that hub. And we have partnered with Ionic Industries over many years, developing different sorts of graphene-based technologies. So today I'm going to talk about recent advances we have made in iodinated graphene oxide. Now, iodine is a material which you can get from seaweeds. So in other words, it is a sustainable material, and I'm going to talk about how we are using this sort of materials for developing manufacturable platforms for safe and sustainable energy storage systems. Well, as my previous speakers have pointed out, energy storage devices are becoming a part and parcel of our modern society, starting from transportation to powering up your portable electronic devices to renewables. All these are driving the market for uptake of batteries and supercapacitors. Now, one thing you have to remember that each of these applications need different requirements, have different requirements of shape, different requirements of size, as well as power capabilities, right? Now, I guess this is a brief history of what we have been doing from 2011. This was back in 2011 was when we started the collaboration with Ionic Industries. Here, just a second. And over the years, this has developed into a spin-off company. And then on the membrane side of things, Ionic Industries did a joint venture with Pneumatic, with the clean tech. It is called Pneumatic, which is commercializing graphene oxide membranes. Whereas Ionic has decided to move on to more of the energy storage side of things. These are some of the prototypes we have developed at our lab and in the stage of commercialization with Ionic Industries. What's going on here? Okay. One of the questions we have to ask is why graphene or graphene oxide materials? Now, Baohua pointed out that there are many advantages in using graphene that includes high conductivity, good thermal properties. But for energy storage applications, one of the key things is surface area, which she also pointed out. Now, it turns out that graphene has a theoretical specific capacitance of about 550 farads per gram, which is essentially unheard of in the literature of supercapacitor materials. The other advantage we have in graphene is that you can have a very large packing density of carbon. And you can go up to about 1.5 to 1.6 grams per centimeter cube. In activated carbon, the maximum you can get to about 0.6 gram per centimeter cube. This is actually a major advantage in graphene materials for making supercapacitor devices. As you can see in this figure here from El-Kadi et al., you will see that if we can go to high energy packing densities of about 1.5, 1.6, we can really achieve energy densities close to 140, 150 watt-hour per kg, right? So that is one of the major advantages of graphene. Now, it also brings new advantages, for example, flexibility, stretchability, variability. The other advantage is that we can make binder-free electrode formulations. Binders are needed for making electrodes, but they also are dead volume, essentially. With graphene or graphene oxide materials, we especially make binder-free electrode formulations. So these are the kind of areas where I think reasons why graphene or graphene oxide materials are so exciting. Now, in our team, we focus on what is called as graphene oxide liquid crystals. What is it? It is a high concentration of graphene materials in a fluid, primarily water or other solvents. The thing which is exciting about this is it becomes like a polymer-like phases. So it has got a polymer-like properties, so it has got viscoelasticity. And this enables us to use processing techniques like coating, printing to make electrodes and devices. We have established, over the years, many papers have come out from our group highlighting what these liquid crystals are, what are their properties, and how we can manipulate them to our advantage. Now, the thing which I'm going to talk about is this iodinated graphene oxide liquid crystal, which is shown here. We can coat them, we can make a film out of it. There is one step which we have developed in Monash. It's called a UV reduction method, which has got many advantages. I will talk about it lately. And we end up with this called iodinated graphene oxide, and you can make them into pouch cells. We have demonstrated here application for IoT transmission, where we call it a battery-less, so we can charge the supercapacitor and send over 100 LoRa signals for temperature and humidity, all right? So an area which we talked about is battery-less IoT sensors. Is powering those systems are an emerging area of energy storage. The production of the ink is very efficient, very simple in a lab scale. This is what the ink looks like. We of course have our secret ingredients, secret herbs and spices into it. At the end of the day, the liquid crystal in a polarized light microscope looks like this. So these are, a liquid crystal of graphene oxide, iodinated graphene oxide. The process of making the electrodes are quite simple. It is compatible to roll processing. We coating, we vacuum dry, and this UV reduction is an important aspect of our intellectual property we have developed. I will talk about it the next slide. And then essentially you have made this electrode when you're limited only by the size of your bulb or lamp, UV lamp, so you can make as large as possible electrodes. Now what we have learned, this is my son, he did this amazing work. We found that there are distinct wavelengths of UV light, which actually makes the graphene oxide more conductive. So some wavelengths promote graphitization, for example, UVC, whereas other UVA or UVB make it more amorphous or make it porous. So we can tune the properties of this graphene by changing the wavelength of the light, actually. So this is a device which my son prepared, a pouch cell, thin film, 1 volt supercapacitor, but we also make 3 volts, 3.5, 4 volts devices in the lab. We charge it, and you can see the LED lighting up, and then he used it to run a small fan. In a sense, it's a charge and discharge device. The properties of this pouch cells are quite nice. You've got a 90-degree Nyquist plot, triangular charge-discharge curves. And we usually do a lot of benchmarking with commercial materials devices. So we benchmarked ours with the CapEx thin line supercap. So this is Mark III. I think we have made further improvements. But you can see that the energy density of this it includes the packaging also, actually. about 2.08 watt-hour per liter, whereas CAPEX is about 0.3 to 0.69 watt-hour per liter. The power densities are, of course, larger in these graphene materials. The only thing which we kind of are behind is the ESR. We have worked on it quite a bit now. I think we are confident we can get to the levels of CAPEX supercapacitor devices. So now in the lab, we essentially have the process of this process in the lab, but each of the processes are actually scalable. We are working with Ionic Industries to produce.
Mainak, I'm going to jump in and interrupt because we're running quite late.
All right.
Can you wrap up very quickly?
Yeah. All right. So
Thank
that's
you.
that's the last part. We are working with AMGC to make this manufacturable. And finally, I just wanted to point out that we have been developed a method where we can classify graphene using machine learning. If companies are interested, we can have a chat. That's all. Thank you.